Today is session 2. It's aimed at walking you through 3 components within Catalyst. So setting out the agenda for today, we will be discussing the compute or function as a service. We will be discussing circuits or the orchestrate part, and we will be discussing storage or backend as a service. A quick overview about Catalyst. This is how the entire Catalyst stack is structured. You have the BAS and the Faas part, which are the storage and the compute part that sit. On top of it are multiple components, which include features like the orchestration part that we saw within circuits. There is the AI component powered by Zia. There are the schedulers, the mail components, the notification, user authentication, and other components. Essentially, on top of this stack is what you build as a developer. You would build a web app. You can build a web app, a mobile app, and a microservice all on Catalyst. So we'll move on to compute, or which is function as a service. So Catalyst functions are custom built coding structures to execute code without having to manage or provision backend servers. What essentially we mean is that we want you to stress more on business logic and developing the baseline code. What we do not want you to do is to spend time on managing servers and managing the entire underlying infrastructure. How functions work are that you can initialize them from the local environment using the CLI, or you can upload them directly onto the remote Catalyst console. You essentially configure for the function, you develop it, you run it, and then there's the auto scale capability that comes in by being serverless. There are 5 different types of server-side functions in Catalyst, which are in both the Java and Node.js programming environments. You have basic I/O functions, which you can use to pass the string as a character. If you need to pass a string, you would use the basic I/O functions. If you want to pass anything but a string, which is anything but a string, which would be covered by the advanced I/O functions. So essentially, HTTP functions that support the headers and the native requests are something that would be covered here. Event functions are configured using the event listener. So anything that needs to be invoked once an event has happened will be covered through the event functions. Cron functions, I'm sure the larger audience would need no introduction on cron functions. So anything that needs to be done periodically or at a particular time interval, that can be handled by the cron functions. And then there are integration functions, which are functions that can help you integrate with other services that Zoho has to offer. There are multiple components and tools that are provided in order to manage functions. So there are security rules which will essentially define the security configuration of your basic and advanced I/O functions, so that you can define who is able to access, who is able to invoke, and so on and so forth. The API gateway will help you and enable you, to create APIs for both these basic and advanced I/O functions and handle the routing, throttling, authentication of client requests. The logs and the APM part are interesting. The logs will tell you, the execution details along with the responses, statuses, and other information. Whereas the APM will tell you how to derive performance reports so that you can make your application perform better. The circuits or the orchestration workflow is something which is essentially meant to automate certain workflows so that you can develop custom logic in terms of, say, if we were to look at an example of configuring certain number of retries in case of a payment failure, or attempting an API push a number of times before a response is received. What's interesting about functions is that the pricing is charged basis the length of the execution. So this is something that will be accessible to you on the pricing page for functions. Or so essentially, it's a composite factor of the execution time in seconds, what it's taking for your function to execute, and the kind of memory that you've deployed. So the number of function executions, which is the number of functions that you're executing, into the number of credits for each function execution time. So for example, if you're executing 2 functions and each of these functions are taking between 1 to 5 seconds of execution time. So that would mean 2 cross 1, and if uh, you're using 128 megabytes of memory, that would be 2 cross 1 cross 1, which would give you 2 credits of the entire operation. So that's how the pricing is done for this. Again, the pricing will be fairly transparent. If I will walk you through the pricing calculator towards the end of the presentation. Moving on to Faas in action. So while we've seen a brief overview about what functions is, it would be interesting to see how functions has been used by an organization to deploy one of their applications. So the organization in question over here is Construction Boss. They specialize in providing CRM solutions for development suppliers in the construction industry. Their clientele predominantly consists of vendors who supply bricks, bathroom tiling, and all construction equipment. So they had a problem. Their problem was that, if you look at any uh, infrastructure project or a construction project, they generally have a completion horizon between 2 to 10 years. Sales team from the construction supply company. So these are people who are supplying bricks, bathroom tiling, and woodwork, as we spoke of earlier. They need to stay aligned and aware about the construction phases and states of each of the products, so that they can actively start pitching to these customers. So imagine that there's a building being constructed right now. That building has gone up to about 10 floors, and the entire structure of it, or the skeleton of it, is developed. Now would be the time when people who do interiors would want to come in, people who do woodwork would want to come in. So essentially, they wanted that, given that there's such a broad time horizon of such development, and everything goes through a different phase, they wanted one solution where data could be captured as to what is the construction status, what all have they already done, what all have they not done, and have it in one place, so that their sales teams, or the sales teams that get access to their data, can be more aware and can be essentially equipped in order to handle such business cases. Imagine someone not knowing that a particular building is reached a construction phase and is looking for tiles, and because of the lack of this information, they start and going to them and pitching to them for concrete. Now essentially, the concrete work is already done, and that's something that's not going to be useful to them, and that would be a perfect lead which would be spoiled. So the problem that they were facing was that, the data was extremely scattered. It needed to be picked up individually from different websites. It was not in one particular format, and the fact that given that it was readily available on a website, the updation was extremely manual in nature. So the entire process was taking a lot of time, a lot of effort, and there was no set uh, I would say process in place, or no set uh, confidence in place that, whatever data is being worked on by the larger team is accurate and is up to date. From a solution point of view, they look to develop a microservice powered by Catalyst. So essentially, what the microservice did was that it helped them fetch the data they needed from various construction companies. So within that, it helped the team to apply secure regional data, because they were able to map the kind of projects that they were wanting to gain information about, map them at a region, and apply specific filters. For example, what is the location, what is the stage of the product, what is the construction type, what is the contract type, and development type. So it would give them a cut between what is commercial, what is residential, what stage is it at. Is it at they're still looking to acquire the land? Have they acquired the land and they're building the structure, or they're doing the interiors? uh, this microservice updated data every night so that the sales team could stay specifically updated on the deals. It also interacted with data from the data provider and integrated it through to their own CRM. So all the tags and filters that we spoke of, the stage of project, construction type, contract type, and development type, and multiple other uh, tags, were then picked up from there and fed into Zoho CRM. Given that they were using Zoho CRM on the back, all of this information was culled from various different sources. It was standardized, and it was then pushed into CRM with the adequate filters, so that their sales team specifically could be aligned with regards to all of this information being available in one particular area. Also, having all of these tags in CRM also help them to make those cuts in order to reach that customer segmentation. So I'll spend about a few minutes on the specific Faas components that were used. So the Catalyst functions, they helped in syncing the data updates at regular intervals in the microservice. So the event functions sync data in the construction was CRM, which was on Zoho. The cron functions updated data periodically in various tabs, including the deals tab. So whatever filters that we had, whatever was being captured, cron functions were being used to push that data constantly into CRM. And the entire microservice on the Zoho CRM application was built and hosted using the advanced IO functions. So circuits, or what we also call as Orchestrate, is Catalyst's orchestration feature that allows you to automate workflows, set up tasks, and set up uh, and essentially, if you have to set up something like a schedule, or if you have to set out something, automate a workflow, that is something that is achieved through circuits. How does circuits work? You build the workflow in circuits, you associate the workflow with relevant functions, you execute the circuits in sequential or parallel order, and you then make or change swaps or tasks whenever which is required. So what advantage the circuits give you? It gives you both the sophistication of allowing a very complex workflow, and it also gives you the simplicity in coding by essentially breaking down each massive workflow into sequential and automated flows which you can manage basis the kind of functions that you are writing. The workflow design is extremely simple. It allows you to reorganize or swap states, rearrange the steps, and perform different steps for different outcomes. It allows a seamless execution experience, and repetitive tasks, multiple retries are something that can be executed or achieved without having to write a lot of code. From a pricing point of view, circuits are charged basis the number of state transitions. So for each state transition that you are wanting circuits to make for you, there will be one credit that will be used. Circuits in action. So let us take up this example of an online ordering flow. So for an online retailer, an ideal flow would be that user makes a purchase. After a purchase, the purchase items are fetched along with the amount and other details like inventory, if it's available, if it's buyable, if it's available at the particular location or pin code that the customer wants to buy it at. All of this information is pushed into a CRM or say an order capturing platform. Post that, when it moves further down into the buy flow, you check for payment. In case of a successful payment, you generate an invoice. In case of a failure payment, you generate a retry, or you prompt the user to uh, change their payment method and try again. Now if you look at this particular example, the sections that have been marked with the blue arrow are something that can be extensively used using Orchestrate or using circuits in Catalyst. All of these workflows, for example, this would find its way into a lot of payment features. You need to define the number of retries that each payment can make, so that you don't want it to go beyond a certain failure rate. If for example, a lot of us must have faced that issue in real time right now, that if you're trying to pay something using Google Pay, in a lot of cases the success rate isn't as high as other different UPI operators. So consider a hypothetical scenario in which you are using a certain specific UPI service and it would fail. uh, if you have circuits embedded into your application, it would help you in defining that retry mechanism and retry logic, which essentially says that for each retry, how many number of retries can you make for the same payment method. If you need to do a retry, post say 3 retries if you want the user to switch to a different payment method, and so on and so forth. So circuits will essentially help you in the entire orchestration and automation of workflows. This particular buy flow being one case in point. So for backend as a service, storage inside of Catalyst offers 3 different types of storage. We have a relational data store, we have a file store, and we have a cache. The relational data store is helps you in storing and retrieving large volumes of data on our powerful managed relational data store. It comes with fine-grained access control. So essentially, all access control can be monitored. You can tag separate users with their own capabilities or abilities to read, write, update. Within file store, again, file store offers the functionality of saving and retrieving user generated content. So a lot of images, documents, and all of that is available at the click of a button. File store also comes with ingrained with inbuilt security, so that you can do access controlled basis different folders and different files and grant those accesses to different people. So we also have a key value based backend cache that helps you accelerate your applications and functions, and which is available on the go. So for data store, so Catalyst Data Store is a serverless relational database that lets you store all of your data for all your serverless applications. You're able to store, retrieve, and manage any consignment without having to worry about provisioning the database. Uh, it offers simplified database administration because you do not have to provision or manage the database server separately. Catalyst takes care of the entire administration. There is very simplified access control, so level of accesses can be customized for different users basis what are the kind of accesses that they need to be given. There are a lot of bulk operations that are available, in which you can fetch or upload any amount of bulk data to data store. And there is easy querying. So the Catalyst data store operates on ZCQL, which is Zoho Catalyst query language, which is very similar to Postgres or MySQL, and it helps you to slice and dice whatever kind of data that you need, whatever kind of data you need to extract out of the relational database. Moving on to file store. File store is the sorry about that, is the file storage and management solution for videos and any other for screenshots, images, videos, documents, any user generated files that you may need as part of your application on Catalyst. It gives you the ability to update, delete, create folders, upload files, download files, delete files and formats associated with the application. Gives you an integrated storage system. You're able to file you're able to upload different types of files, handle them differently. There is ease of use. It helps you organize files in one single repository. Within that, you can make different folders. Within those folders, you can use the simplified access control to give accesses to different types of people. So one particular example of file store in action was a particular organization was building an application for a healthcare setup in Africa. Now, this particular healthcare setup wanted different departments within the hospital to have different accesses to different reports, and then have certain admin users that would have access across all departments. So that this is something that was done with file store. So they made essentially different uh, locations for each department. For each of those users who were entering or who were wanting to access data from these particular departments, there were different user access controls that were created, so that limited information was available to the right set of people. The cache in Catalyst can support high-speed data retrieval with minimal latency. It's best suited for memory-intensive and dynamic data operations. The auto-scale part in cache helps you uh, in scaling up automatically and scaling back down with fluctuating requirements in your application. Uh, you do not need to worry about the server architecture management. So there is zero server management when you're looking to use Catalyst cache. And then there is an automatic fail-safe handling, which helps the developer in moving away from the constant monitoring and manual recovery tasks in case of a downtime. From a pricing point of view, data store has two types of costs, an operational and a storage cost. The operational cost varies with regards to the insert, delete, update, select, or search operation that you would make. The storage cost, about 2 GB of storage comes free, which is approximately 1 million rows. Beyond that, for every additional MB that you take in, there are a credit charge of 5,000 credits for approximately 500 rows. Pricing for the file store, essentially the operational cost is basis the operation type, which is an upload will be 4 credits, a download will be 2 credits. The storage cost, again, up to 10 GB is offered for free as 0 credits. Beyond that, each GB that you take up will be 50 credits on charging. The cache as well, the put operation will be charged with 2 credits. The get operation is charged at 1 credit. From a storage point of view, 10 MB or approximately 2000 keys are free. Beyond that, additional MB would cost you 50 credits. So we'll be briefly going through the Catalyst cron and ZCQL part as well, because that forms an integral part of what we've been discussing today. So the Catalyst cron is essentially a job scheduler. Again, cron is something that I don't think would need a lot of introduction with the audience. I'll highlight a few features that Catalyst cron has. You'll be able to automate schedule-based tasks to reduce manual workload. You can integrate with other components to to execute a chain of processes using functions. You'll be able to periodically synchronize data with external components like third-party applications. There is ease of access via the application platform's SDK and APIs. And you'll be able to view usage information such as execution count, active and inactive jobs via the metrics. The ZCQL, which is Zoho's own Catalyst, Zoho Catalyst's own query language, is very similar to MySQL and Postgres. It allows you, it provides you the functionality to perform data manipulations in the Catalyst data store. You'll be able to do retrieval, insertion, updating, and deleting. DML queries like join, group by, order by, and where condition will be are something that you can use. And basic arithmetic operations are also baked into ZCQL so that numeric functions can be handled through the ZCQL query. Let's walk through an example where we see Backend as a service in action. So Build HR was a strategic HR management consulting firm. They wanted to build the entire performance management process, the entire hiring process, and the evaluation process to support the entire HR infrastructure. Now, while there were solutions available in the market, there was nothing that was unified, which they could use and they could pitch to their customers. And this is something that they came out with the thought to build. So, in order to move away from the pen and paper era of assessments, they wanted to develop an application that could be accessed from anywhere. The evaluators could access it from anywhere, and the fact that they could do evaluations for hiring through this particular application. So there were multiple pre-employment testing solutions available, but they wanted to build a cloud-based application so that they could have an easy to access environment where applicants and evaluators could join equally at ease and complete the process faster. So the solution that they saw was that they built an online evaluation platform. This consisted of two parts. There was an admin console for the HR team of the organization that was using this service, and there was a candidate login, which each candidate or student would log into and access the test and evaluation. So functions or parts of Catalyst that were extensively used over here were around user authentication, where different roles were created for the admins and for the applicants or the test takers, so that different accesses can be given to different types of people. The data store stored a lot of data heavy. This was a very data heavy application, because when you're receiving an applicant, you want different types of information to be captured up, apart from their normal candidate information. So the data store kind of served as the storage to keep all of this data in place. Apart from candidate data, it also had assessment data. So essentially, if you would create a new table for a master set of questions with a master set of solutions, this also provided the functionality to upload answers by a specific candidate into the same database, and through ZCQL operations come out with a report on what has the candidate scored. The file store was used for evaluation certificates, anything around the file. So for this particular use case, it meant a lot of documents for the applicants, a lot of evaluation certificates, and other files that were required for the hiring or evaluation purpose that the organization wanted were something that was stored in Catalyst file store. That brings us to the end of the three components that we had planned for today.